Hello students, this is Nilanjana Sanyal from onlinemathtutor.me and ePortioner.com. Today we'll be solving a linear programming word problem graphically. So let's start. Now this is the question. A shop sells large and small oranges. A girl buys L large oranges and S small oranges. She buys at least 3 but fewer than 9 large oranges. She also buys fewer than 6 small oranges. The maximum number of oranges she needs to buy is 10. There are 3 subparts. Subpart A is write an inequality for each statement. Subpart B is graph the inequalities, leaving the region which satisfies the inequalities unshaded. And subpart C is using the graph state one solution which satisfies all the inequalities simultaneously. So let us start with our answer. Now we will be solving each subpart separately. Okay. The first subpart is write an inequality for each statement. The first statement is a shop sells large and small oranges. We do not have any inequality corresponding to this statement. Coming to the next statement. A girl buys L large oranges and S small oranges. They have given us the two variables. We cannot frame any inequality from this statement as well. Coming to the third statement. She buys at least 3 but fewer than 9 large oranges. Large oranges means L. She buys at least 3 means equal to 3 or more than 3. She can buy 3 large oranges or she can buy more than 3 large oranges. So the corresponding inequality is L is greater than equal to 3 and she buys fewer than 9 large oranges. So L is less than 9, fewer than or less than, same thing. So L is greater than equal to 3 and L is less than 9. Combining these two inequalities, we have this condition. 3 is less than equal to L. Therefore, L becomes greater than equal to 3 and L is less than 9. Okay. Now, next statement. She also buys fewer than 6 small oranges. Small oranges means S. Fewer than 6. That means S should be less than 6. So our corresponding inequality is S is less than 6. Next statement. The maximum number of oranges she needs to buy is 10. So she is buying some large oranges and some small oranges. But the total should be less than or equal to 10 because she needs at most 10 oranges. So we have our third inequality. L plus S is less than equal to 10. Coming to the second subpart. Graph the inequalities leaving the region which satisfies the inequalities unshaded. So this is the graph paper. Coming to the first inequality, which consists of two inequalities. First is L is greater than equal to 3 and L is less than 9. So we are drawing two straight lines which represent two equalities. We have learned how to graph an inequality in our last lesson. So we will be drawing a straight line corresponding to L equal to 3. This is a solid line because this inequality contains this equal to sign as well. So L equal to 3 is a solid line. But L is less than 9. We have drawn this line L equal to 9, but this is a dashed line because we do not have any equal to sign in this inequality. Now we have to shade the region which is having L values more than or equal to 3 but less than 9. You see, if I take a point, this point is having an L value equal to 5. Between 4 and 6, this is 5. So, every point lying on this horizontal straight line is having the L value equal to 5. So, it is more than 3 but less than 9. This is L. This is the L axis and this is the S axis. Okay, I have taken only the first quadrant because number of oranges cannot be negative. So you can take any point you like in this region bounded by these two lines, and you will be finding that the corresponding L value will be greater than 3 but less than 9. So we can shade this part which will be representing this. Greater than 3, L is greater than equal to 3 but L is less than 9. But they have asked to graph the inequalities leaving the region which satisfies the inequality unshaded. Since this part satisfies the two inequalities, we cannot shade this part. This should be kept unshaded. We have to shade which parts? This part and this part, right? So, we have shaded these two parts. This is L greater than 9 and this is L less than 3. Coming to this inequality, S is less than 6. So, again we will be drawing a straight line corresponding to S equal to 6. So, we have S equal to 6. This is 6. So, all points lying on this straight line will be having the S value equal to 6. Now, this straight line is dividing the entire region into two parts. Suppose we take a point from this part. What is the S value for this point? It is 2. So, it is less than 6. All points lying in this region on the left hand side of this line is equal to 6 will be satisfying this inequality S is less than 6. But we cannot shade this portion because they have asked us to leave the region which satisfies the inequality unshaded. Since this part is satisfying the inequality, we will be shading the right hand side part. Coming to the third inequality, L plus S is less than equal to 10. Again, we will be drawing the straight line corresponding to L plus S equal to 10. Okay. So, this is the straight line corresponding to L plus S equal to 10. Now, we have to see which part is satisfying this inequality L plus S is less than equal to 10. Whether it is this part or this part. So, let us take up a point from this part. Okay. So, this is S equal to 2 and L equal to 4. So, 4 plus 2 is equal to 6, which is less than 10. So, this part is satisfying the inequality L plus S is less than equal to 10. And since this equal to sign is present, this line is a solid line. But we have to leave the region which satisfies the inequality unshaded. So, we will not be shading this part. Instead, we will be shading this part. So, we have shaded this part. Now, you see, this is the area which is not shaded. So, this is the part which is being simultaneously satisfied by all the three inequalities. Why am I saying simultaneously satisfied? Because we have shaded the regions which are not satisfying the inequalities. This region is left unshaded because it is satisfying every inequality. So we could not shade this part. Coming to the third subpart. Using the graph state one solution which satisfies all the inequalities simultaneously. So, One solution can be that the girl bought 6 large oranges and 2 small oranges. You see, 6 and 2. This is the point. This is a point lying within this region, so it is simultaneously satisfying all the given inequalities. 6 plus 2 is less than 10, so this inequality is being satisfied. 2 is less than 6, so S is less than 6. This is getting satisfied. And L is equal to 6. So L is greater than 3, but L is less than 9. So 6, 2. This point is satisfying all the 3 inequalities. Therefore, one solution can be that the girl bought 6 large oranges and 2 small oranges. You can find other solution as well. Let us take 4. 4 large oranges and this is 3. For S, it is 3. So even this is another solution. We can have this point as well. So the girl can buy 4 large oranges and 3 small oranges as well. 4 plus 3 is less than 10. So this inequality is getting satisfied. S is equal to 3. So it is less than 6. Therefore, this is getting satisfied. And L is equal to 4. So L is more than 3 but less than 9. So even this is getting satisfied. So we have more than one solution, but one of the solutions can be that the girl bought 6 large oranges and 2 small oranges. This is our answer. So students, let us stop over here for now. Please give this video a like and share this video with your friends. Please subscribe to my YouTube channel for more math videos every week. I'm an online math tutor and I make math videos mostly on algebra and trigonometry based on CBSE, ICSE, IGCSE and West Bengal State Board math curriculum. Thank you for watching. Have a wonderful rest of your day. Bye.